The critics argue that Einstein's equations of gravity, which are used to describe wormholes and black holes, only work for gravity, and not the quantum forces that govern radiation and subatomic particles. In order to truly understand the nature of these phenomena, a new theory is needed that can unite the laws of gravity with the quantum theory of radiation. Throughout the world of science, this is called a theory of everything, a single theory that can unite both Einstein's theory of gravity and the quantum theory. Michio Kaku, who's a renowned theoretical physicist, has been working on a theory of everything for decades, too. While there are lots of different versions of what this could be, the only one that has shown promise is superstring theory. Superstring theory unites gravity with the theory of radiation. The theory proposes that subatomic particles are actually tiny vibrating strings, and that the universe is a symphony of these strings. Just as different musical notes correspond to different vibrations of a violin string, different particles in nature correspond to different vibrations of a superstring. One of the fascinating things about superstring theory is that as a string moves in time, it warps the fabric of space around it, producing black holes, wormholes, and other exotic solutions of Einstein's equations. This means that superstring theory not only unites Einstein's theory of gravity with the quantum theory, but it also explains many of the mysterious phenomena that we observe in the universe. But there's something about this theory that really throws a wrench into how simple it might sound at first, but in a way, makes more sense too. This requires 10 dimensions of space-time in which the strings can vibrate. This is quite different from the 3 dimensions of space and 1 dimension of time that we experience in our everyday lives. It's difficult to imagine what these extra dimensions might be like, but physicists believe that we can't see the extra dimensions of space-time directly, but we can observe their effects on the world that we experience. In particular, the vibrations of the strings in superstring theory can produce waves of energy that travel through the extra dimensions of space-time. These waves can manifest themselves as particles with different properties, such as mass and charge. In this way, describe how the universe evolves from there. There are already solutions of string theory that describe the evolution of our universe since the Big Bang, based on some reasonable estimates of its nature. This is a significant achievement. Another more ambitious path is to demand that string theory selects its own initial conditions. That one is a little more complicated, and less likely too. So in a way, we've already narrowed things down significantly. But here, Michio Kaku puts another spin on it all. Maybe the Big Bang wasn't really all that big after all. He says, it wasn't a massive explosion as many might think. It also didn't make a loud noise like one might expect from a bang. The Big Bang theory doesn't provide an explanation for what caused the supposed bang or how it occurred. It simply states that it did happen. The truth is, we need a theory that can account for what happened before the Big Bang. This is where string theory comes in. According to this theory, our universe might have been formed from the collision of 2 separate universes, or it could have emerged from another universe like a baby being born from its mother. This connection between universes is called a wormhole, which is like a tube connecting 2 bubbles. It's possible that we may have already discovered evidence of this umbilical cord that connected our universe to another. In a way, we could just be living inside a black hole this whole time but not know it. Think about it. Because we exist in 4 dimensions and can't see anything beyond it,